Hi, everyone. Nice to see you all again. Um, at least one new face here. John is going to be a master's student under Lindsay at UBC, right?
That's correct.
Sure, we'll see him around a little bit more often here. Do you mind just giving a quick background introduction? We can go around and just introduce you to some of the people here if you haven't met them yet.
Sure.
Not sure if we've done that.
I graduated in 2017 with a bachelor's in physics from Santa Clara University, small school out in California. And after that, I started working for Zong Geophysics, and I've been there for the last 4 years. And yeah, I came directly there from there to here. So
Excited. Oh, there's Lindsay. Wasn't sure if you'd be able to make it today.
Sorry, I'm late. I was hoping to be able to come and introduce John, but hopefully somebody else has, and you're all giving him a warm welcome.
We're just getting started.
Excellent.
Yeah. John, there's probably a few faces on here that you haven't met before, at least. I'm not sure if, have you been to one of the SimPEG meetings yet? I can't remember.
and no, this is the first one.
Okay, that's what I thought. You probably don't recognize Ben, Mike, or Shalom, Ben, because you've met Devin and myself before. Ben and Mike, do you mind just giving a quick?
Yeah, sure. Yeah, I joined the group fairly recently as well. I'm working at GeoSci.xyz with Dom. And yeah, I'm using SimPEG, but not contributing much so far, but hopefully that's going to change in the future.
Mike, has things been going well down in there in California for you?
Yeah, no, things are going well. I'm Mike. I did my PhD with Doug, and at the same time as Sagi and Lindsay and all those guys, so overlapped with most of these folks. I'm now working with the U.S. Geological Survey, and we're kind of using mostly MT, but also some potential field data to try to study some volcanoes. Some here in Clear Lake, and I just got back from a trip up to Alaska where we were studying a chain of volcanoes up there as well. So good stuff.
Sounds hot. Shalom.
Okay, yeah. Hi, John. This is Xiaolong. I'm a PhD student in the University of Houston. I focus on the jointing inversion using the potential field data sets and analyze the uncertainty. Nice to meet you.
You too. Nice to meet all you guys.
And Sagi, we're just going around and having people that introduce themselves to John. He's Lindsay's new student if you haven't met him yet.
Hi all, I'm Sagi. I used to be in UBC. I got PhD with from Doug and used to work with Mike, Lindsay, and I am at Stanford now as a postdoctoral fellow and mostly working on water problems. I kind of switch it to minerals from water, but still interested in mining. Actually, we just presented some of the mining work about the EM inversion in a conference. Anyway, so that's I'm great to see you all.
Yeah, thank you. As far as an agenda for the meeting, I don't particularly have anything, so I just give some quick reports from people and then move on from there. I see Thibaut had added something, but he's not on there yet. I was talking with him yesterday about it. He was trying to do some PDE simulations of the magnetics problem. And we realized that, oh, that also is that boundary condition, it's using like boundary condition codes in there. So we need to update that to the newer calling convention and more general calling convention that we were using. It should be pretty straightforward compared to how the DC simulation is. So
yeah, I think I don't know. I think that PDE version has been, we haven't touched it for several, 3 or something like that. So yeah, I would be surprised that would work. yeah, good luck with Thibaut. And I'm happy to help. And I think I've thought about that quite a bit of, and you can actually do a linear version of PDE. So rather than
Oh,
like
there's,
so anyway, like I have thought about that problem. So if you need some like a different thoughts, let me know.
yeah, TiVo, I thought TiVo wanted specifically like to be able to handle the high susceptibility values. So it wasn't necessarily like a linearized form of it that he was.
Right. Then I think just going straight for PDE should be better.
And TiVo, was there anything else? I'm sorry, just going down through the quick report. Wasn't seeing you here yet. Anyway, well, I can move on. So I've my stuff that still just like kind of, I haven't been putting too much time into the tetrahedron meshes. I've just kind of been picking at it. It's still coming together really quickly though. Like even what time I do have put together, it just kind of falls together very nicely actually. And I think all the tests pass. The ones that I've written so far, like they all passed, and then mostly just need to get some interpolation matrices made for it, and also add some boundary condition stuff like boundary just identifiers. And that should be about it for that tetrahedral mesh, and we'll be able to get that in, play around with them. I think we've talked about it before, but I think at this point having like generators is a little bit outside the scope of discretize at this point. Like there's a lot of great tetrahedral mesh generators out there already. We should at least just be able to interface with them and use them before we start trying to like, implement our own stuff to create things. But we should at least be able to do simulations on a tetrahedral mesh.
One of the things that we did with SimPEG, we had that 3D pseudo-section plot that required Plotly. And it was a utility, but it would import that functionality if you had that package. And I think we could do a tetrahedral mesh utilities where it will import, you have those available if you have the right package. So we could just kind of make, I don't know what you call it, a wrapper or whatever it is. We could write that kind of a thing.
Yeah, we've got that kind of general functionality for discretize right now. Like there's mix-in classes that get in that where the meshes have additional functions on them if you have like available packages.
Yes, you want to do it through a mix-in as opposed to a as a utility. Because I guess if I was finding it, I would want it as a utility.
Yeah. If it's like, as far as like reading in like a gen formatted like mesh, like reading in the output of something, that would be like okay,
that would be mixed in.
Yeah, or like EKs, obviously they have a tetrahedral mesh support, so we can read it in from there.
Okay. Yeah, I think we're on the same page.
Yeah.
Joe, what are you envisioning with this? Like, are you actually going to develop like all this like operators for tetrahedral mesh as well? Is that what?
Yeah, I've done that.
Oh wow, that's great.
Yeah, that's why I said it can't. That's why I say when it came together really quickly, I was surprised. I was like, oh, I thought I was going to have to do a lot more work to get them all together. I was like, oh, okay, never mind.
That's pretty cool. Huh. Wow. That's exciting.
Yeah, it was, there was a lot of stuff like I was building up kind of like the structure behind it. Like I was thinking about, okay, what do I need to keep track of? Well, I need to keep track of like, for every cell I need to keep track of, it's like the nodes on it. That's like the general structures, you give it like the points. So you give it a list of nodes and you give them their connectivity. Like you define like the nodes that are in every cell, and then it goes through and builds everything from that. So just like, okay, from that, we can figure out the faces that are on each thing and the nodes, like which nodes are on each face, and then which edges are on each cell and which edges are on each face. And then go through there. And then once you have like those few lists, like all those matrices build very quickly.
Wow, that's pretty cool. So can we technically do like most of the problem would work? Like, so if you just switch from tensor mesh to tetrahedral mesh, it would work. Wow.
And I
Yeah.
mean, yeah, I mean, there's a few little things that will not work because like those inner product matrices are not easily invertible. They're like, they would require like a matrix inversion code just to work. To do some of those formulations that require like the inverse of a face product matrix. Those aren't going to work, and it's hard to make them work properly. But it's the same thing like I talked about before, the curvilinear also should not work on those meshes or on those problems for the same reason. It's mass, like its inner product matrices are not diagonal.
Yeah, and moving to regularization, I guess, also inversion, like you probably need a little bit better. I think there were a couple of papers about that recently came out. So.
Yeah, I mean, they're nice. You don't have to worry about hanging faces or hanging notes on anything, right? Like, is that part of it?
Yeah. One thing might be interesting, what I learned when Lindsay and Dieter worked on that paper about CSCM. The current octree mesh actually have a bit of problem, like that expansion rate of 2. It's actually just too much to handle the general like a marine CSCM types of problem. So, which actually could be a problem when we actually want to, let's say, invert for CSCM data. Anyway, and it seems like the unstructured, like that tetrahedral mesh worked well for like by looking at the other code. So
yeah,
it'll be
it
fun
does
to
work.
actually play with that.
Yeah.
Oh, great.
And other than that, I did a pass through all the GeoSci lab stuff to get them updated, refreshed, kind of doing, just getting rid of deprecated calls to matplotlib and stuff like that. Just reduced all the warnings that are coming in. And then I'm probably going to be tagging a 0.15.1 release of SimPEG this afternoon, just to catch the release, like the recent small bug fixes we've been merged into master. So that's what I got for my quick update. Devin?
Yeah, I guess one thing I want to bring up is pushing the discretize API across the finish line. I think you've done your final review. I've done my final review. The only thing really left is to cache the kind of expanded tutorials section. Because right now we're not ready to release it, and it's right now it's showing up in the build. So I think doing that part, we need to do that, or maybe
What part are you referring to?
I'm just wondering, do we make, or it could be something that was in a git ignore and then maybe not in a git ignore on another branch, and why it's showing up. So I guess if you're not seeing it as any problems, then it should be fine. I was wondering if the latest tutorials that we had put, that we were developing for discretize, is part of the branch being merged, or whether or not that's actually not a problem.
I don't think so. Did you? So I dropped a link a few weeks ago to like look at that live, or like I put it up on a GitHub pages page for me. I didn't like, it didn't show up there, and that's kind of what I built it from, and they won't look too different from that. So if they're not there, and it's probably a local, it's something.
Okay, then it's a local thing then. I haven't dived into it, but okay, I'm not worried about that now.
Yeah, I think I'm pretty happy with the documentation. We just got to get that build, get that installation thing, that collapse, that Sphinx extension that enables the collapse function. We got to install that on the testing environment.
Yeah, and that thing was a little interesting because it's compatible with Sphinx 3.6.5, it's not compatible with the latest release of Sphinx. And
Yeah,
I was kind of, go ahead.
Conda should be able to pick that up. I
I
guess
think
we
I tried.
install like dependencies.
Yeah, so it's a useful little function, but it definitely makes things a little more interesting in terms of compatibility and kind of the environment you're building it in.
Mm.
So yeah, it's something to consider. So that sounds like that's the only part that's really left to do on that project.
It is finalize the
Yeah.
text. And then
Uh,
it should be it should be ready to like merge as soon as we decide on a logo. I'm not sure. I think I was hoping to do like some social thing, but I could
Like
also
a
just put it up for a vote now. If you
like a
guys,
discretized logo? Like, do we have some options, or is somebody creating something from scratch? I thought we already had the three cubes.
so I was wanting to have like another, I can share some of the things I was working on. Like the point is like we want it to be a little bit noticeably different than SimPEG. Like notice that, okay, well, this is discretized, it's the SimPEG, but they should be related to each other.
Interesting. Related but different.
Yeah, I can show you some of the things.
I'm actually very curious. I want to see this.
Just a quick note, I don't think we should vote on it in this meeting. I think we need to get input from other folks, but I think you should absolutely show them and we can get input. It'd be good to hear from Rowan and Dieter and others too.
Yeah.
People will submit their logos, and the best one wins.
Where was it? Okay.
Just send it to, well, I guess maybe everyone else wants to see it. You could just send it to me in Slack if you want to.
Oh, I'd like to see it.
All right.
I'll put them on. Let's see. You guys can see this, and then so this is one of them.
Oh yeah.
I'm all in dark mode, so sorry. Just like kind of see like it just kind of related to it, but notice like a little bit different. So this is the SimPEG logo by comparison, right?
Yeah. Yeah, it's good because it's actually there's continuity between the style of it, but it's a different logo. Oh, and it kind of looks like a lowercase d.
Yeah, and then we kind of did this as well. So there's that. There's just like this, like discretized along with the SimPEG logo, like similar to it as well.
Actually, that is kind of a fun idea though, to do the different shapes, right? Because there's cylindrical meshes, things that are more cubic, and then now your tetrahedral ones, and you're having the different basically volumes next to each other.
Yeah, that's the thought of this one, and then it obviously looks like a D. But that's kind of like at least some of the ones that we're working on right now.
Yeah, I actually like that.
Like I said, they look noticeably related to SimPEG logo. Like they all do. I think if we keep that color scheme, it'll probably be a good basis for it. Kind of like the difference between like the NumPy logo and SciPy. Like they're the same overarching organization, but they're slightly different purposes.
All right, and then so the next thing that I worked on, and I mean, if we have time, I can go into it in more detail, but I had started, I started a Google Doc and I started sketching out a way that we would be publishing our code validations. So we'll drop that in the chat. So yeah, I mean, I started to work around. I got a bit of an example that maybe I could show you guys in like 5 minutes on how I've sort of organized this. And I'll just start with the mags. If you give me screen shareability, I will go for it. Okay. So just the general structure, I kind of figured we want to, I don't know if it's going to be a website or if we can deploy it other ways. I'm looking for any input on that, but probably want to section it by geophysical method. And then each particular kind of geophysical experiment or each scenario, maybe it's like a, oh, I don't know, the EM response over a 1D layered Earth or something like that. I have a notebook that can be used to generate the web page, or we could do it from a .py if we wanted to. And then, so you kind of up front, you would see an explanation of the geophysical scenario, and you would see the comparisons of the different codes. So I turned one of these notebooks into a web page, or just I saved it as HTML. And basically we would, as that section, we'd say, okay, we're simulating TMI data over a block and a half space. So this would be in the magnetic section. We explain what we're modeling, and we would have what coding packages or what formulations are being compared. And we could link to documentation, we could link to an online manual or a website. So now you know what you're modeling, you know which codes we're using, and then you'd have basically the lines of a notebook that would download any files from as like the .tar. We just import things from an online storage place. And then maybe we would plot something like what the model is and the survey geometry. So give you a picture of what you're modeling, and then like plot the simulated data using both codes in some fashion. And in this case, it was important to actually have some kind of, I don't know, assessment and error, or the difference between the two codes. So up front, really, we're trying to say what we're modeling, what coding packages were compared, and then show visually that comparison. And if somebody wants to, I mean, all of these simulations, they should be reproducible. It's kind of the point, is somebody could say, okay, well, how did you actually get that working? So then you could go kind of down a level and have access to notebooks or instructions on how to reproduce the results. So now I have a notebook that says, okay, how can I reproduce the data using the SimPEG code? And going through the notebook and simulating that. And for SimPEG, or sorry, for the UBC GIF code, you would still want to have a link to the manual, and make it clear that you would need to actually get a hold of the package somehow, and then maybe some instructions on how you would do that. So if you are a UBC GIF consortium member, maybe you've purchased a license, maybe you work for an academic institution and got an academic license, you would then actually have the executable, and you would be able to run both of these and reproduce it. So that's sort of what I'm thinking with this. And the way that I've written this, if I did do it as a .py, I think it would render kind of the same way that our Python examples would in that API documentation. So
this looks really nice, Devin.
thank you.
One thing I would encourage you to look at for deploying is Jupyter Book. I think that might actually be a natural fit for this, rather than turning all of these into .py files, because one of the things that's important for especially some of the ones where you're reproducing examples from SimPEG is I suspect that they're actually going to take a while to run.
Yeah, they're not too bad actually. And
okay, well,
yeah.
Okay, well, that's a good good thing to know. With Jupyter Book, it basically like it is a nice lightweight way to just take a collection of notebooks and turn it into a resource. So you don't have to sort of rewrite everything. The other thing is if we do end up having bigger examples, we can just pre-run, or you could even grab a notebook that ran on the cluster, for example, and have that be included. Whereas the Python files, it's going to try and rerun it. And that could get kind of heavy. So but yeah, I'd encourage you just take a look and see what you think, but it might be a little easier to deploy than a full-on sort of read the docs site.
Yeah, and I agree with you. And I did kind of consider that part where I would like to be able to publish the notebook after it's run, as opposed to getting it to kind of have to run every single time. I'll look into Jupyter Book. Do you have much control over sort of the hierarchy of everything? I guess I'm just thinking about our GeoSci labs and how we kind of use notebooks to create structure, where you can kind of go into this section and then go into this section.
Yeah, take a look. So actually the Jupyter Book docs is built in Jupyter Book. So that's a nice way to get a tour of kind of what how that works. And so yes, you can sort of have the same nested tree approach. We can combine markdown files with notebooks and things like that. And then what's nice is like by default, then you can always download any one of the pages as a notebook. And we didn't have to do anything special to make that happen. And actually another thing that's kind of cool is you can connect it up to a hub. So we could connect it up to Binder or a Jupyter Hub running anywhere else. And people can actually just hit like a play button and run it, which is kind of cool.
Okay, yeah, this actually sounds like the best option.
I dropped the link in the chat, but I'll put it in Slack, or I'll put it in the notes here too.
Yeah, that's fantastic. Because I agree with you that it doesn't need to be a heavy read the docs website. And if anything gets, I guess, improved or adapted, it would be nice to be able to just upload a latest one. Okay. I guess I'll find out, but with the Jupyter Book, I'm assuming that I need to provide it with something that kind of defines my Python environment, or am I just putting up published notebooks?
Take a look at the docs. If we're just putting up published notebooks, you don't have to do too much, but because we actually do probably want people to potentially be able to run these on Binder and or elsewhere, you'll want to do an environment.yaml file, just like we would in any other repository that specifies like this version is SimPEG and whatever. And that way people can actually sort of take those notebooks and rerun them.
Okay, that's awesome. But in terms of the organization of the notebooks, you guys are pretty, like, does that seem like what you guys thought? Kind of a title page of these are all the comparisons, and then you can go down a level and see how each one was reproduced. Everyone's pretty happy with that. Okay, so I'll look into the Jupyter Book, and I'll start adapting the rest of those validations for kind of upload, or maybe I'll do a test one first and see if we like it.
And Deb, where this is going to be sort of hosted? Is that under SimPEG website or SimPEG docs?
Well, I'm thinking, well, as Lindsay said, I think we're going to put it up on, I guess, Jupyter Book, and I don't know if that's connected necessarily to SimPEG right now, but it should be. And I guess somewhere on the SimPEG website, we would have a page about code validations that would bring you to the Jupyter Book. So it serves a lot of purposes. One of it is it'll validate SimPEG code against analytic solutions and also against other coding packages, namely for us would be UBC GIF at this point. And how fast does it run, performance stuff. And already with some of these validation codes, it's led to improvements in performance and other things from like the UBC GIF code side, and I think also in SimPEG. So by doing these validations, we find little things and we ask, oh, can we do this better? Or why is this not identical when the formulation appears to be the same for all intents and purposes? And then we find those details, and it's actually leading to notable code improvements.
Yeah, I'm just kind of curious where, like, it's a great idea. It's just curious where is a good place to put it in. I was kind of wondering whether it's worthwhile to put it as a separate, like some sort of separate from website or SimPEG docs, because it's somewhat, there's a fine line, I guess, like because it's more closely related to testing, I think, which should be like I don't know. It shouldn't be hosted actually in the SimPEG repository. It should be hosted in a independent place. So I think I still need to learn, I guess, how JupyterBook works and yeah, do some learning for that before I have all the answers. But it seems like it's going to be hosted, and it's going to be, the files will physically be located in, I guess, a separate repository that will be, I guess, connected or uploaded to JupyterBook. And from the SimPEG website, you would get linked to that stuff. I feel like that's the general idea. I'm getting thumbs up from Lindsay, so we're on the right track. That's basically it for me.
Thanks, glad that like it is helpful to have the comparisons and at least have other people, like, gives weight to the accuracies of SimPEG, even though, I mean, I know we do test them against the analog functions, but again, we wrote the tests, so. Anyway, Lindsay, what do you got?
Yeah, just a couple quick updates. So the line source implementation, at least on the time domain, is ready for testing. So Devin, you mentioned you might be willing to take a crack at that. If you'd like to go for it, that'd be wonderful. I'll be mostly offline for about a week. So if you run into any roadblocks, feel free to tag me and we can figure it out next week. But if you're willing to take a crack at it, that would be great. And we should be able to hook that up pretty quickly to the frequency domain code. I haven't gotten around to it. If it looks obvious to you, Devin, from the pull request, feel free to maybe branch off and take a pass at it. But if not, that's fine. We can take care of it when I get back. The other one that's a quick update that's mostly relevant for Dieter, who's not here, but we'll put it in the recording for him, is the casing simulations repo that I use for my thesis stuff. I'm trying to do a bit of cleanup there, get it onto the latest SimPEG, and also help fix it up a bit. It was one of those, it was a bunch of code that I wrote when I was learning and excited about object-oriented programming. So it's so overkill on object-oriented, it's really bad. So trying to make it less bad. But at least right now, some of it still runs again. So I'll update that and ping him. So, but that's about it on my end.
Any other quick reports? Anyone?
I don't know if Dom and John have met yet. Might be worth a quick hello if you're both.
Hey, Dom, nice to meet you.
Did we were interacting on Git, right? Were we? No, on Git on Slack. Is that right? On Slack or
Just Slack, but
yeah, just Slack. Yeah. Can do you mind just telling me again what we were talking about?
oh, I don't think we were interacting.
Oh, okay. You talking to other people, yeah. Well, I'm Dom anyway. I'm mostly on the potential field side of things and inversion, that kind of stuff. So if we have a chance to collaborate, that'd be great.
John's working on his master's here at UBC, and so he's interested, just getting started, and interested in the carbon mineralization project. So hopefully there'll be lots of connections there, Dom.
There we go. Okay, now my brain is lining up. Thanks, Lindsay.
No worries, no worries.
Well, welcome to UBC. That's awesome. You'll be working with Lindsay. That's
Very
brilliant.
excited to have him here.
Yeah. Are you from BC, or where you come from?
I've been living out in Reno working for Zong Geophysics for the last 4 years. Yep.
Right on. So from the States.
Yep.
Welcome to Canada.
So you're the real geophysicist.
I guess so.
Yeah, it's great to have somebody have a practical, real experience.
Are you all theoretically geophysicists?
Not sure who we are. Like something related to geophysics, I guess.
Theoretically.
Term, very broad.
Okay. If anyone doesn't have any other quick reports or anything that you'd like to bring up.
I have a quick report. We gave a presentation in IAGA. Not sure anyone of you actually recognize what this means. But actually, this was my first time actually present there. I think it's mostly like a very I'm not sure what's like the real identity of, but I think it's mostly kind of like global geophysics, very deep structures. MT is their main interest. So Lindsay was a convener, so that was main motivation to submit. But so it was it's an interesting experience. So we submitted an abstract and we presented the work that I collaborate with Dieter. And yes, I shared the poster in some of the Slack channels. So if anybody is interested, they can take a look. But I think in general, like they are getting more interested in the near surface. So application of MT for the near surface. I thought that's some of the interesting kind of discussion that we had in that conversation. And another thing I just posted in that curve note. So Dieter's code, actually we used slightly different definition of data. So rather than breaking that apart as a real and imaginary, so we're directly inverting for complex value or amplitude and phase. So that makes a slightly different derivation of complex data to either amplitude or phase. And I kind of, I derived and I got the right solution, but I actually don't know why that's the right solution. So if like I wrote down the math and some of the assumption that I made, which I'm not sure. So if somebody can take a look and actually let me know why that's the case, I know that's the true and that actually works. And what's an interesting thing is the derivative of the phase in regard to the complex value is actually 0. So if you think about that, the gradient of the phase is 0, which was a bit surprising to me. So there's actually no need to compute the JT back of this of the phase. So most of the information is most of the gradient direction is coming from the amplitude. It sounds weird, but I think I'm right because I tested the order test and then everything worked. But I don't know why. So there's some interesting, maybe there's a potential that I could be wrong, but if somebody could take a look and think about that, and that would be an interesting discussion that we could have later. And potentially that could help improvements in our EM code a lot, I guess, because the current structure is quite kind of inefficient in a way, because we're solving for real, solving for imaginary, which is not necessary. But anyway, so that's a couple of thoughts that I had.
I'll take it. I can take a look at it too. See what's going on.
Is the MyTex accepted? What are you guys starting already working on this, Lindsay?
It hasn't been accepted yet, but we're starting to get going. I mean, the acceptance rate of my tax is pretty high, so I anticipate it should all go through. It's just a matter of time. Yeah, so we'll get up and running next week with John on that. So quite excited to be starting to dig in there.
We free them.
Hey Joe, hey Joe. So how about the cross gradient?
Oh, I just haven't had a lot of time to get on top of it right now, but it's coming.
Okay, okay.
It's on my radar.
Mhm. And another PR for the depth weighting, I just follow your comments and delete some volume and normalization. So yeah, we already got a view from the DOM and maybe need another view. If you got any chance to take a look, that would be great.
Yep.
Mhm.
Oh, I think I remember when I was looking at it. So when I was referring to the normalization, I just meant like don't have any volume terms in it. You can still like divide it by its max value if you want. That's fine.
Oh, it's fine.
Yeah, that part's fine.
Okay.
There's no volume normalization or volume multiplication.
No volume, just okay.
Yeah, I started working on my side to standardize that whole volume thing. That's going to deserve its own pull request, and I think at the same time we should just try to reduce the number of regularizations. It's a bit ridiculous that we have that simple, and then as far as it's basically everything the same thing except for like a few flags, right? So I think we should try to simplify it a lot. Like Tikhonov is just a matter of like a scaling factor. It could be all just flags, I think, if you want to use, the usual. And anyway, I'll sketch up like a new structure, and then we can talk about it next time.
Good.
Yeah, I'm looking forward to the field data results from the Sagi. I just take a look at the poster. The synthetic results looks pretty good. Looking forward.
Usually the synthetic looks pretty good, so
Yeah.
don't be too optimistic. But we're just ready because the major challenge was the notations and the complex value, and they provide like apparent resistivity and phase. So yeah, we had to kind of come up with better form of data like an amplitude. So we're just ready to run the amplitude CSMP data. So yeah, I'll keep you posted.
Mhm.
One other quick question for Xiao Long. I see you've got an abstract ready for your seminar next month. Is that good to go live if I hit the publish button?
Maybe I need to more editor. Yeah, maybe I will do a few more editor in this week. When I done,
Okay.
I can send you the message.
Sure, that sounds good. No rush. I'll be away probably till next Wednesday, but if we can get it out sometime next week, that would be great.
Oh, next Wednesday? Okay, got
Yeah.
it. I can make it within this week.
Awesome. Looking forward to it.
Next week.
Good.
Have a good week.
Take care, everyone.
Bye.
Hey guys.